So excited because this is super fun. Graphing in vertex form is by far my favorite way to graph a parabola. Y equals a times the quantity x minus h quantity squared plus k. These are things that look like this. You want to make sure that you add that squared in there. I think it slipped off of the notes page somehow. So make sure you put the squared in so that this makes sense. So when we graph these are our ax squared parabolas. So after you stretch them, all you have to do is translate them horizontally h unit and vertically k units. Tricky part is with the h, making sure you take the opposite of what you see. So coming from inside here, we want the opposite of what we see. So we see a positive 1 in here. Our h is a negative 1. You take the opposite of what you see. You're thinking, what lets that equals 0? Whereas the k, you take the same as what you see. So our k is negative 2. Always weird for students to remember that. So our vertex, we don't have any work to do. We just pair the h and the k together and we're done. The axis of symmetry still goes through the x coordinate of the vertex. So we are having an axis of symmetry at negative 1. Our a is 1/2, which is greater than 0. So we open up. We are a happy parabola. That means we have a minimum number of face muscles being used to smile. That minimum is negative 2. It occurs when x is negative 1. Since our a value is 1/2, which is less than 1, we have a vertical shrink here. So our pattern is 1a, 3a, 5a. Our a is 1/2, so 1/2, 3/2, 5/2. So starting at our vertex, negative 1, negative 2, we go over 1 and up 1/2, over 1 and up 1, 2, 3/2, reflecting those points over our axis of symmetry. If we go over another one, we go up 5/2, 1, 2, 3, 4, 5/2, and then over 1, up 7/2. All of those points are actually on our grid. We don't go off the grid till after that. So we get this nice arcing parabola. Our domain is all real numbers. Negative infinity to infinity. Our range, our smallest y value is right here. It's our minimum value of negative 2. From that point, we increase. So negative 2 to infinity, or y has to be greater than or equal to negative 2. Our transformations, we had a vertical shrink. Come on, pen. Vertical shrink. By 1/2. And then we translated one left and 2 down. Our y-intercept when x equals 0 is now harder to find. We want to plug into our equation. When we plug in the 0, y equals 1/2 0 plus 1 squared minus 2. It doesn't just give us the y-intercept like the c used to in ax squared plus bx plus c. So we get y equals 1/2 times 1 minus 2, or 1/2 minus 2, which is negative 3/2. Or the point 0, comma, negative 3/2. When our x is 0, our y's are 1 and negative 3. When our y is 0, our x is 1 and negative 3. Or the points 1, 0, negative 3, 0. We've already plotted the HK and drawn the points for our parabola, so we are done ski.